This is R.D. Sharma Solution, Class 12, Chapter 18. Maxima and Minima we are taking exercise is 18.4. Now this is a very easy exercise, and if you have done from 1 to 3, this 0.4 is very easy. Like Rahul Gandhi says, let us do it khatakat, khatakat, khatakat. So this is a new thing here. -2, 4 and it's 4.5 actually, the last one. Now when we make a curve, we have certain, crest and trough. That means the maximums and minimums, the local maxima, the minima. So if you are given certain points, like these are the critical points, so these are the points on which you have to find out the maxima or minima. So specific point are being already given. Previously, we have to find the critical point, then we can find out whether it is minima or maxima. Here already the critical points are given. So first thing what we do here is the differentiation. When we differentiate, this becomes 4 minus 2x divided by 2. So it's 4 minus x. And in order to find out the maxima and minima, we just put f dash x is equal to 0. So when you place it 0, 4 minus x is equal to 0. That means x is equal to 4. Now x is equal to 4. This is the critical point. And it still lies in the critical point list which is given in this question. -2, 4 or 4 then we have 5 or 4.5. So if you know how to solve -2 and 4, you can solve 5 and 4.5 as well. Okay, we are going in the right direction because x equals to 4 is the critical point. That also lies in the question being formed by the whosoever has made this question. So -2, 4 and 4.5 are these three critical points. One of them we have just found, and we have connected that the clarity here. That okay, we are on the right track. The next thing what we do here is we have to take all these critical points, and since already the critical point is there with us, we just have to find out the minimum and maximum value. So we will place these three values which are given in the question in the original equation, which is 4x minus x square by 2. So f minus 2 we have to do, f4 we have to do, and f4.5 we have to do. So I'm just placing the -2 value in the original equation, which is 4x minus x square by 2. Here also f4, it's 4 into 4 minus 4 square by 2. And as I said, the third number can be 4.5, it can be 5, because in different edition of R.D. Sharma, the numbers are different. But the logic remains the same, it will never change. This is -10, f4 is 8, f4.5 is 7.875. Now, what is the absolute minima and absolute maxima, or absolute minimum or absolute maximum? See, there are certain local minima maxima. So I made a graph. Now here one maximum will be the maximum of all. That is called the maximum. One minimum will be minimum of all. That is the minimum. But if you take any maximum which is maximum than the other around, this is called local maxima or local minima. It's not the highest one, but it is higher than the other one. That is called the local maxima and local minima. But when it comes to certain points, specific 2 or 3 or n points, then we say that whichever is the maximum in these given points is the absolute maximum or absolute minimum. I hope you have the idea now about the different kind of maximums we are talking about. Now you have to see the ascending order here. That is, the lowest one is -10. Then we have the 7.875 and the highest one is 8. So this -10 comes at f minus 2. So x equals to -2 will give you something. Here x equals to 4 is giving you 8, which is the maximum. Highest value is 8 at x equals to 4. So f4 is equal to 8. Similarly, this is the highest value I am talking about. Coming to the lowest value, which is the lowest among all these three. The lowest among all these three is -10. And -10 has come from when we place the value as -2. So at x equals to -2, we get absolute minima or absolute minimum, which is actually equal to -10. How are we going to write about it? So all these English language or these things you have to follow. X minus 2 whole square plus 3 in -3 and 1. Already the interval or the critical points are being provided. We just have to differentiate this function and we have to place it as 0 and see if we come up with some additional critical points. If it is not there, then we will check only on -3 and 1. Now f dash x we have already done, and we are placing it as 0. 2 into x minus 1 equals to 0. That means 2 cannot be 0. So x minus 1 has to be 0, x equals to 1. X equals to 1 already is in the list of critical points, which is -3 and 1. So we are following the right track, and the question is also saying giving us the right critical point, -3 and 1. The second thing will be, see, just check this function at -3 and 1. F -3, just put it here, -3 minus 1 whole square plus 3. 1 when we place, it will be 1 minus 1 whole square, that is 0, and plus 3 directly it will come as 3. When you compute this is 4 square is 16, 16 plus 3 is 19. So you got 3 and 19. 3 is lower than 19, or 19 is higher than 3. 19 we got at f minus 3, and 3 we got at f1, that is the critical point 1. So the lowest or the absolute minimum value is 3, which we received or we got when we placed x equals to 1. Similarly, the absolute maximum value we got as a 19, which is the maximum value, this one, 19. And this we got when we had x equals to -3. This is the reference for you. You can follow this reference and solve it. Next one is this one. This is the expression. And we have to find out the absolute maximum and minimum at the critical points 0 and 3. Now we have to check whether we have more absolute minimum or maximum points to be checked or not. That is the critical point. So what do we do here? We have to differentiate this. So first thing is the differentiation of this 3x raised 4 minus 8x cubed plus 12x square minus 48x plus 25. So this step I am differentiating it, and differentiation is quite known to you, quite well versed you are with differentiation. I hope that we have this differentiation. Now just place it as 0. You can take a 12 common because we can see 12 is everywhere in these terms, and just divide both terms by 12. We only get x cubed minus 2x square plus 2x minus 4. We can take x common from here, x square common from here, x minus 2 will be there. And here we can take 2 common, x minus 2 will be there. Now taking x minus 2 common from all these, x square plus 2 will remain inside. X minus 2 equals to 0, that means x is equal to 2. X square plus 2 is equal to 0, that means x square equals to -2. This second term or second factor is not going to give you any critical point, because x square plus 2 can never be equal to 0. It can only be 0 when there are no real roots. There can be conjugate or say real and imaginary complex kind of roots, but we are not going to deal with this right now. X square cannot be equal to -2 in this case. We are only left with x equals to 2 here. So we have 0 and 3 already there in the question being given. But from here we got 2. There are 3 points here, 0, 2 and 3. And all these 3 points we are going to check for the actual value. So this 0, 2, 3 has to be placed in 3x raised 4 minus 8x cubed plus 12x square minus 48x plus 25. So I am now placing this value and trying to find out the different values we get after placing these critical points here, 0, 2 and 3. So once you place this f0, 0 is 25, f2, this f2 is -39, and f3 we are coming up with another number. And in these 3 numbers, we have to see the highest one and the lowest one. So when we have f3, we got 16. So if you go with the ascending order, it's -39. And then we have 16 and 25. So let us write it like this. We have -39 here, -39. This comes at f2. It is lower than 16. That comes when it is f3. Then we have f0. F0, this is 25. This is when we had f0. So minimum is -39 at f2. So at 2, x equals to 2, we got the -39. So this is the absolute minimum value. And f0 gives you absolute maximum value. This is the reference which you can follow in order to solve this question. And for those who want to do it by themselves, very essential. This will take in the next discussion. Thank you so much. Take care of yourself. Next exercise we'll do fatafat.